Okay, this is an explanation for PT39 game 3. And so in this game, we have the variables S, T, U, W, and Z. And these are all children. And of these children, we know that 3 of them are left-handed. So we have 3 left-handed children and 2 of them are right-handed. We just don't know which ones are left-handed and which ones are right-handed. And so we also know that each of the 5 children was born in a different one of these 7 years, 1990 through 96. And so I'm going to write 1990 as just 0 to keep it more simple, and 1991 as 1, and so on. So then we have 1992, 1993, 1994, 1995, and 1996. And so we actually have more spaces than we do variables, right? We only have 5 children, but we have 7 spaces. And so not all of these spaces are going to be used. We have to have 2 that are left empty. Okay, so our first rule is that no 2 left-handed children are born in consecutive years. So having someone who's left-handed go in the next year as someone else who's left-handed, that can't happen. Similarly, we can't have 2 children who are right-handed going in years next to one another. That's our second rule. Our third rule is that Sarah, who is left-handed, so S is left-handed, and S is going before U. Zoe was born before both Theo and Will, so Z is before T and W. So that means we know the relative ordering of all 5 of our letters in relation to at least one other letter, right? S, U, Z, T, W. We have rules about all of them in terms of where they have to go in relation to at least one other letter. A left-handed child was born in 1991. So we know that whoever was born in 1991 is left-handed. Uma, who is right-handed. So they just told us U was right-handed. So I'm just going to add that into that rule. U was born in 1993. So U, who is right-handed, has to be born in 1993. So I'm also going to draw around that to let us know that that's set. And that's all of our rules. So if we know that U is right-handed, and we know that we can't have children that are both right-handed being born in consecutive years, we know that whoever is born into, if there is someone born into, they have to be left-handed. Same with 4. But actually, since there's someone being born in this year that's left-handed, doesn't that mean that whoever's being born in the second year can't be left-handed, right? And so if they can't be left-handed, but they also can't be right-handed, then we can't really have anyone in this space, right? Because having someone that's right-handed breaks this rule, because we know that U is right-handed, but having someone that's left-handed breaks this rule, because we know that someone that's left-handed has to go in space 1. And so no one is going to go in space 2. So let me just write an X there. No one's going in space 2. And then we also know that whoever's going in 0 has to be right-handed, right? Because if there is someone going in the space, because whoever's going in 1 is left-handed. Okay, and then we know that S is left-handed and S has to go before U, right? And so the only space before U where someone that's left-handed can go is 1, 1991, right? So S has to go here. So I'm going to rewrite this as S, who is left-handed, goes here, because we know that for sure. Okay, and then now we really only have these 3 letters to fill out, and we know that Z has to be before T or W. So really the only 2 places Z can go is in 0 or 4, right? Because 2 letters have to go after Z, both T and W. So in this second situation, T and W can go 5th and 6th, right? In whatever order. We don't know yet. And then we know that in the situation, the first scenario that we have drawn out, T and W are going somewhere in 4 and 6. Well, in this situation, we know Z has to be right-handed, right? And we only have 2 right-handed people. We know that Z is going to be right-handed over here and that U is going to be right-handed. So since T and W have to be left-handed, they have to go in 4 and 6, right? And we know that they're left-handed. T, W, they're both left-handed here. And here we know Z has to be left-handed. This has to be right-handed, whoever's going in this year, and this has to be left-handed so that we don't have left-handed people in consecutive years or right-handed people in consecutive years. So these are really the only 2 situations that can happen, right? We know that S has to go in column 1 and U has to go in column 3. We put Z in the 2 places that it can go. And when Z goes in the column with 0, T or W have to go in 4th and 6th. And when Z goes in 4th, T or W have to go in 5th or 6th. So these are all the scenarios that can happen. So we've just created worlds, and these are the 2 worlds that we're dealing with. And so you can rewrite each of these rows with like one row where T is going 4th and W is going 6th, and another row is where W is going 4th and T is going at 6th, and that will give us 4 different worlds, right? So this game has 4 worlds. I'm just going to look at them with 2, which is a little bit condensed. But you can write it out as 4 different worlds. And so in this situation, nothing's going at 2 and nothing's going at 0. In this first situation, nothing's going at 2 and nothing's going at 5. So question number 12 is asking which one of the following could be an accurate matching of each child with the year in which that child is born. Okay, so in A, we're looking at an example where Sarah is in 1990. Well, we know Sarah can't be in 1990, so we can cross that one out. Here we're looking at Sarah in 1991. Okay, that works for both combinations. U is at 1993. That works for both combinations. T is at 1994. That means we're looking at the first combination, right? Because in this combination, Z is at 1994. So T is at 1994. That's fine. Zoe is at 1995. If T is at 1994, Z is not here, right? Z has to be in the column with 0. So we can cross out B. C says Zoe is at 1990, so that's the first row. Then Sarah is at 1991, that's fine. Uma is at 1992, that can't happen, right? So we're going to cross out C. Next combination, Zoe is at 1990, so we're looking at the first combination here. Sarah's at 1991, that's fine. Uma's at 1993, that's fine. Theo's at 1994, that's fine. Will is at 1995. That doesn't work, right? Because we know that we can't have anything in 1995 because T and W would both have to be left-handed, and they can't go next to one another. So D is out, which means our answer must be E. Let's see if it checks out. Zoe is at 1990. That works. Sarah is at 1991. That works. U is at 1993. That works. Theo's at 1994. And then Will is at 1996. That all of those can happen, right, at once. So E is our answer. Next question, if Sarah was born before Zoe was born. So if Sarah is born before Zoe, we are then looking at this second combination. They're asking which one of the following statements cannot be true. Will is left-handed. Will can be left-handed, right, according to this over here. So let's see. Okay. So yes, Will can be left-handed if we select Will here and Theo here, right? Then Will is left-handed and Theo is right-handed. So that works. That can be true. Zoe is left-handed. Well, Zoe we know has to be left-handed, right? So that can be true. Theo was born after Will was born. Well, Theo can be born after Will, if we select Theo here and Will here, right? In this scenario, Theo can be born after Will. Uma is born after Zoe. So they're saying, hey, can Uma be born after Zoe? No. We know that Uma has to come before Zoe in this scenario, so that would be our answer. Just to go over the last option, no child was born in 1990. No, that has to be true, right? We know that there is no one born in 1990. So we can also cross out E. Next question, which one of the following must be false? None of the children was born in 1990, nor was a child born in 1992. So they're saying which one must be false. It absolutely cannot happen. So can we have a situation in which no one is born in 90 or 92? Yes, we can. So this second situation here, no one is born in 90, no one is born in 92. That's not a must be false thing because we have an example of it, right? So that works. That's not must be false. None of the children were born in 92 nor 5. So that's talking about this situation actually. So that can happen. There is a situation in which no one is born in 92 and 95, and so that's not something that must be false. None of the children was born in 1994 nor 1996. Okay, that never happens, right? There is no situation in which someone is not born in 94 and 96. Both of our examples have someone in 94 and someone in 96, right? So that is a must be false thing. We can't have that happen. Just to look at the last two options, one of the children is born in 1990, so that would be talking about this situation, and another in 93. That can happen, right? So that's okay. That's not something that must be false. One of the children was born in 93 and another in 95. So that would be talking about this situation. Someone is born in 93, someone is born in 95. That's fine. So that works. We can also cross that one out. And then number 15, if Theo was born after Will was born, so Theo's after Will. So that means we want Theo to go 6th here and Will to go 4th here. And we want Theo to go 6th here as well and Will to go 5th here, right? That's how we would have Theo being born after Will. So then they're asking, hey, how many sequential orderings of the children can you have? Well, we know that we have these two general options, right? And if we pick the orders for Will and Theo, then this option would just be Z, S, U, W, T. And this other option would be Z, S, U, W, T. So if Theo is born after Will, we only have, sorry, I accidentally put Z here. So Z in this second combination is actually going 4th, right? So they ask for sequential orderings. So we actually have two sequential orderings, right? We have this one over here, which came from this world that I've drawn up here, and this one, which came from this row over here. If we had two options, right, where Z hadn't been here and Z had been here instead, then this would just be one sequential ordering, right? Even though W is going in different places here in 4th, and then later it's in this other combination, it's going in 5th, this is still only one sequential ordering, right? It's ZS, UWT, ZS, UWT. And so if these had been our two examples, the answer would have been 1. But since we know that in the second combination that we pulled from the second row, Z has to go here, right? It's got to be S, U, Z, W, T. It's going to be two different sequential orderings. I'm just going to erase this to clean up some of what we've drawn. Okay. Next question. So now they're asking if none of the children was born in 1995. So because they're asking about no one being born in 1995, we know we're looking at this combination, right? Then which of the statements must be true? They're asking for something that has to be true, right? Does it have to be true that Theo was born in 1994? Let's go back to before we filled out those circles. Does it have to be true that Theo was born in 1994? No, because Will could be born in 1994, right? And Theo could go in 1996. So that's not a must be true thing. That does not have to be true. So we can cross that out. Will was born in 1994. Does Will have to be born in 1994? No, Theo could be born in 1994 and Will could go in 1996. So that again is not something that must be true. Since we don't know anything about Theo or Will in terms of where they have to go, it's T/W for both space 4 and 6. We can also cross out C, right? It doesn't have to be true that Will is born in 1996. Will could be born in 1994 and Theo could be born in 1996. So we can also cross out C. D, Zoe was born in 1990. So is it a must be true thing that Zoe was born in 1990? Yes, because in this situation where no one is born in 1995, Zoe has to be born in 1990, right? So that is a must be true thing. E is saying Zoe was born in 1994, which doesn't happen. T or W has to go in 1994, so we can cross out E. Okay, next question. If Theo is right-handed, so if Theo is right-handed, then we are looking at this situation, right? In this situation, the only options Theo has are to be left-handed or left-handed, right? Both of these spaces have people that are left-handed. And so the only situation in which Theo could be right-handed is in this example. And if Theo is right-handed, Theo can't go in the sixth space, right? Because then Theo would be left-handed. So we're picking Theo for 1995 and W for 1996. So now they're looking for statements that must be false except. So something that does not have to be false. So we're looking for something that could be true. So Theo was born in 1996. No, Theo cannot be born in 1996, right? That is a must be false thing. So we're going to cross that out. Will was born in 1995. No, that also is a must be false thing, right? We know for sure, for a fact, that Theo has to be born in 1995. Uma was born exactly 3 years before Theo was born. Uma was born 3 years before Theo. 1, 2, no, right? This is only 2 years before. This has Uma 1 year before, 2 years before. So that's not our answer. And then our next answer option says Zoe was born exactly 1 year before Theo. That is our answer, right? Because Zoe was born just 1 year before Theo. So D is not something that must be false, right? That's something that's true. Our last one, Will is right-handed. That is something that's false, right? We know for sure that Will has to be left-handed. So we can cross out E as well. Number 18. So if Zoe was born before Uma was born, so this is a situation in which Zoe was born before Uma, and this situation, Zoe's born after Uma, right? So we're looking at our first row here. They're asking which one of the following statements must be false. So is it a must be false thing that no child was born in 92? No, that's a must be true thing, right? We know for sure that no child was born in 1992, so we can cross that out. No child was born in 1995. We know for sure that has to be true, right? That's not a must be false thing. Theo is left-handed. Theo is left-handed, right? Because no matter whether you put Theo in 1994 or 1996, Theo has to be left-handed in both of those. So that's also not something that must be false. Zoe is left-handed. Zoe can't be left-handed, right? Zoe actually has to be right-handed, so that is something that must be false. D is our answer. Let's just check out E. Will is left-handed. Well, similar to C, where we said Theo is left-handed, Will also must be left-handed, right? Because whether Will goes in 4 or 6, Will has to be left-handed. So we can cross out E as well. And then that's it for this game.